Hello, my student. Today we talk about second order linear differential equation. This is section 2.1. First, I give you a definition. Homogeneous linear equation we call equation where you have, this is equation linear for your function y and first and second derivative, and because homogeneous, this means is equal 0. Okay, let's we have some linear equation. This means this equation called homogeneous equation. Okay, let's go. We have some linear differential equation. It's non-homogeneous. Then we can rewrite this equation for this shape always. Y equal fx. Okay, this is equation 1, this is equation 2, and equation 3, whereas we have second derivative plus px y prime plus q qx y equals 0. It's called associate homogeneous equation. Okay. And now we have some theorem. Let's tell us, let's function y1 and y2 to solution equation 3. Equation 3. Then function y equals c1 y1 plus c2 y2. It is also solution. Equation 3. How we can prove this fact? First found first and second derivative of the solution. Y first, this will be c1 y1 for a derivative plus c2 y2 derivative, and second derivative will be c1 1 second plus c2 y2 second. Plugging function first and second derivative for our equation, we have plus px multiplied by y first plus c2 y second first, and plus x c1 y c1 y1 c2 y2, and this is equal, if we separate for this way, we have y first second derivative plus px plus c2 px y2 first and plus qx y2, and this is equal. Because y1 solution our equation and y2 solution our equation, this means we have c1 multiplied by 0 plus c2 multiplied by 0. It's exactly equal 0. We prove our theorem. Proving is done. Okay, example. Let's go y equal cosine x. Y first and y second is sine x. And we have equation second derivative plus function equals 0. You can easily check y1 and y2 is will be solution our equation. Okay, what is will be first derivative for function y1? Minus sine x. Second derivative, it will be minus cosine x. Y second, first derivative is cosine x. Y second derivative is minus sine x. I'm prepared and now I check. Okay, checking y first. I have minus cosine x plus cosine x equals 0. True? True. Checking y second. We have minus sine x plus sine x equals 0. 0 equals 0. True? True. This means we have function y equal c1 cosine x plus c2 sine x, solution our equation. Okay. Now we have some definition. Two functions fx and gx call linear independent. Independent on some interval a b if not exist constant c such as fx equal c gx. We have one more definition. We call Wronskian two function g. This kind of is determinate f g f prime g prime. And here we have some theorem. Two function are linear independently if and only if Wronskian from two function is non-zero, or linear dependent if Wronskian is 0. Okay, let's prove. We are proving something opposite. Let's our function linear dependent. This means exists some constant c, such as f equals cg. Then is Wronskian will be f g f prime g prime, but it will be c g g c g prime g prime. Counting, we have c g g prime minus c g prime g, but is exactly equal 0. Okay. And here we have very interesting fact. It's one more theorem. If we have if for function, for equation, okay, this is writing better. Homogeneous equation second order. You have y1 and y2, two linear independent solution. Then solution c1y plus c2y will be y2, here y1, will be general solution. Then it will be general solution. This means we don't have any other solution except this one. Okay. Now we're talking about linear second order equation with constant coefficient. We try now study how we can solve a linear equation with constant coefficient. Let's go. We have this kind of equation. Second plus by prime plus cy. This is we talk about homogeneous equation. And I try found my solution like e to the power rx. This means first derivative it will be r e to the power rx, and second derivative it will be r squared e to the power rx. Plugging all this one is my equation 1. Then we have square here, a r squared e to the power rx plus b r e to the power rx plus c e to the power rx need to equal 0. Factoring, we have r squared plus b r plus c equals 0. Because either any power is non-zero, this means this equation have solution only if a r squared plus b r plus c equal 0. And now we have a couple of theorem. I think it's 2 theorem now. First one give us if r1 and r2 two real and distinct root characteristic equation, this one is called characteristic equation, two real and distinct, this means r1 not equal r2, root equation 2, then y equal c1 e to the power r1x plus c2 e to the power r2x, general solution, our first equation. I think now we need solving some example when you can see how it's work. Okay, example. Let's go. We have 2y second derivative minus 7y first derivative plus 3y equals 0. Okay, it's mean we have homogeneous equation with constant coefficient. Now we write our characteristic equation. It will be 2r squared minus 7r plus 3 equals 0. And this will be 2r minus 1. It will be r minus 3 equals 0. We have first solution is will be 1/2. Second is will be 3. And this means general solution our equation it will be y equal c1 e to the x squared x over 2 plus c2 e to the 3x. Okay. Because we're solving, our characteristic equation is quadratic equation. Now we know what is doing if we have two real different root. But what happened if we have equal real root? This means here we have theorem. It tells us if characteristic equation 2 has equal real root, r1 equal r2, then y from x equal c1 plus c2x e to the power rx will be general solution equation 1. Okay, doing one more example. Let's go. We have second derivative plus 2y first plus y equals 0. And here they ask us not general solution but particular solution. This means we have initial point y from 0 equal 5 and derivative from 0 equal -3. Okay, first you write our characteristic equation. This will be r squared plus 2r plus 1 equals 0. This means r plus 1 squared equals 0. This means first one equals second one and equal -1. This means our solution will be c1 plus c2x e to the -x. This is general solution. Because we need found particular solution, first we need found derivative. It will be c2 e to the -x minus c1 plus c2x e to the -x. Okay. Plugging our initial point y from 0 equal, it will be exactly c1 and need be equal 5. Y from 0 equal c2 minus c1 and need be equal -3. Plug, I think I have c2 equal to. This means my particular solution for this initial point will be 5 plus 2x exponent -x. Okay. Solving a couple of examples. Something similar for your homework. Number 4. Here you have some differential equation, second order, two function, and initial point. And here we need first verify the two solution, y1 and y2, and then found particular solution. Okay. First, write our equation, y second plus 25, y equal 0. Here you have y first equal cosine 5x, y second equal sine 5x. And initial point here is y from 0 equal 10 and y prime from 0 equal negative 10. Okay. First we verify this is our solution. This means I need found first derivative for each function. It will be minus 5 sine 5x, and second derivative it will be minus 25 cosine 5x. For second function we did same. It will be 5 cosine 5x, and second derivative it will be minus 25 sine 5x. Okay, I am prepared, and now I start plugging. Checking function y1. Second derivative minus 25 cosine 5x plus 25 y, this means y1 25 cosine 5x. Need be equal 0. 0, yes, 0 equals 0, right. Taking function y second. It will be, I don't need parentheses, derivative here, okay. Taking y second, we have second derivative, this means minus 25 sine 5x, and plus 25 y second, this means plus 25 sine 5x equals 0. True? Yes. This means general solution here, y equal c1 cosine 5x plus c2 sine 5x. What I say, this is general solution because cosine and sine is cosine 5x and sine 5x is two independent functions. You can check. For example, because Wronskian will be cosine 5x sine 5x, derivative minus 5 sine 5x, here is 5 cosine 5x, and we have 5 cosine square 5x minus negative 5, this means plus 5 sine square 5x. Now this is exactly equal 5. This means this two function is linear independent. Okay, I'm clear here. I want to clear here. I think it's better if I'm skip, but okay. I'm trying. All right. This will be more clear what I'm doing. Okay. Here we have y from 0 and y first derivative we need. It will be minus 5c1 sine 5x and plus 5c2 cosine 5x. Okay. Y from 0 equal 10. This means plugging we have c1 equal 10 and y prime from 0 equal 5 c2 equal negative 10. This means c2 equal negative 2. And now particular solution is will be 10 cosine 5x minus 2 sine 5x. This is exactly particular solution what they ask us. Okay. Okay, and doing number 24, here we have two functions. Number 24, first function is sine square x, and second function is 1 minus cosine 2x. And here we need checking this function is linear dependent or independent. Yes, we can write Wronskian, but I think in this situation is a little bit easier. Only remember some trigonometric identity, and here we have second function simplified. You have 1 minus cosine square x. I write this way, sine square x. It will be 1 minus cosine square x plus sine square x. But 1 minus cosine square is sine square. This means here I have 2 sine square x. This means my function gx is exactly my function fx twice. This function linear dependent. Okay. Number 38. Here we have homogeneous equation with constant coefficient. This means 4y second plus 8y first plus 3y equals 0. First we write characteristic equation. It will be 4r squared plus 8r plus 3 equals 0. Solving 2r plus 3, 2r plus 1 equals 0. This means r equal negative 3/2, r equal negative 1/2. And general solution here is will be c1 e to the negative 3/2 x plus c2 e to the negative 1/2 x. This is general solution of homogeneous equation. Number 46. Here is opposite. Here you have, oh, I say 46, but I write 48. Okay, it's no big deal, but 46. Here we have general solution, y equal c1 e to the 10x plus c2 e to the 100x, and we need build differential equation whose general solution we have. Okay, this means r1 here is equal 10, r2 equal 100, and our characteristic equation is will be r minus 10, r minus 100 equals 0. This means it will be r squared minus 110 r plus 1000, or it will be second derivative minus 110 first derivative and plus thousands. Function equals 0. And I show you number 47. Usually I show even number, but this is 47 is interesting because here we have general solution equal c1 plus c2x. What is show us? First, because we have a linear combination here, this means r1 equal r2. But because you don't have any multiplicator e to the power, this means here both of this number is equal 0. This means here we have r squared equal 0. What does mean? It means second derivative of your function equal 0. This is general solution for this differential equation. Before we moving forward, now we need to talk about Euler equation. It's some special type of equation which you can use substitution solving like homogeneous equation with constant coefficient. Euler equation is equation this type: ax squared second derivative y plus bx y prime plus cy equal 0. Okay. And now we're doing this kind of substitution. Let's v is natural logarithm x. And our function v now is work like function depend v who is depend x. What does give us? What will be first derivative? It will be derivative respect x. It will be dy dv times dv dx. Dy dv, we don't know what is it, but dv dx will be 1 over x. What is second derivative y? It will be, take it first derivative one more time. Take a derivative on first derivative one more time. What we have here? Use product rule and chain rule for function y. We have minus 1 over x squared dy dv. And here we have plus 1 over x dy dv second times dv dx. But this is give us 1 over x one more time. This means second derivative will be minus 1 over x squared dy dv plus 1 over x squared second derivative dy dv. Okay. Now use all this one and plug in for our equation. What we have? Ax squared plus, I write here, plus bx. Here is 1 over x dy dv and plus cy equals 0. Okay. Distribute and open. What we have here? We have a second derivative plus b minus a first derivative and plus cy. Looking here, now we have homogeneous equation with constant constant coefficient, and we can found r1. Characteristic equation will be a r squared plus b minus a r plus c equals 0. If you have r1 and r2, two real numbers, what you have? You have first solution is will be e to the r1v, but e to the r1 ln x, it means x to the power r1. And similar we have x to the power r2. This means general solution here it will be c1 x r1 power plus c2 x to the r2 power. Great. Okay, what we need to remember about all of this writing? We need to remember characteristic equation, how we can rewrite, and final answer. Okay, doing some example. This is example 54. Here I have 4x squared second derivative y plus 8x first derivative y minus 3y equals 0. This means a equal 4, b equal 8, c equal negative 3. Characteristic equation will be 4r squared, b minus a, this means 8 minus 4. Okay, maybe I write this one, then you can easily remember what is it. And minus 3 equals 0. This means 4r squared plus 4r equals 0. And 2r plus 3, 2r minus 1. Here is r equal negative 3 halves and r equal 1 half. And general solution will be c1 x to the negative 3 halves power plus c2 x to the 1 half power. This is all what I want to tell you about section 2.1. Doing your homework, please. Come in my office time. If you have question, ask me. Okay.